Hello, I want to go over this Toeplitz Matrix problem in LeetCode. So essentially, it's a matrix that um, all the diagonal elements are essentially the same. So here we can say 5 and 5 is the same, 1, 1, 1 is the same, 2, 2, 2, 3, 3, and then since 4 and 9 are essentially the first and last elements. Um, this they don't have any other diagonal. So this is true. This is true. So and then here's another example of it being false. As you can see, 1 is not 2. So this would return false. Um, so starting here, uh, first we'd like to get the rows and columns of the matrix. So rows is equal to matrix dot size int columns is equal to matrix at array 0 dot size. So this is going to grab however many vectors are within the big vector, and then this is going to grab the first vector within the big vector, the amount of elements within that first vector. So next we're going to declare uh, a bool. So I will call this bool is Toeplitz. I think that's how you spell it. Yeah. And we're going to set this to true. So we're going to assume that the matrix that we input is in fact a Toeplitz. So next, we're going to need two for loops. So the first for loop is going to be in charge of the rows. So int row is equal to 0, while row is less than um, rows minus 1. So this is going to be our boundary. So while the row is less than um, however many rows we have minus 1, um, we keep iterating. It's so we stay in bounds within the matrix, and then plus plus row. Or I should yeah, plus plus row. Next, it's the columns now. So for int column is equal to 0, while column is less than columns minus 1. So again, to keep us in bounds, plus plus column. Now in here we want to compare. So essentially, for this matrix, we're essentially comparing. Since we're starting off here, we're comparing 0, 0 to 1, 1 because that's the position of this one right here. So we would want to say um, we'd have to an if statement. So if matrix at array at the current row in the current column. So say we're starting off here. If matrix at the current row and current column, which is 0, 0, is equal to um, the matrix at array row plus 1 and column plus 1, we're just going to say this. These tuplets, keep it true, right? So essentially this is saying that if element at 0, 0 is equal to element at 1, 1, um, keep it true. So it's still true. And then here, once we get to this element, once we iterate to the rest of the matrix, once we get to this element, which is uh matrix at 1, 1, if matrix at 1, 1 is equal to matrix at 2, 2, because as we can see here's 1, 2, 1, 2, um, this is still set to true, right? And this is going to be true for all of these other matrices, right? All the other elements within the matrices. And then we need an else if statement. Else if matrix at array row and column. Now this time we're going to say it does not equal matrix at array row and column plus one, sorry, plus one. Forgot the one right there. Plus one and plus one. We're going to say is Toeplitz is equal to false now, because once we find this single one to be false, then we know that the whole matrix is going to be false. And then we want to break. So we don't want to continue iterating um, through the inner loop. And then um, outside of so for the outer loop as well, we're going to say if two is Toeplitz break, which is essentially just saying the same thing here. This is saying if it's not true, break. So if it's false, break. And then we're going to finally return is Toeplitz, right? Okay. So for here in the main, we're going to call solution, and then we're going to say vector int matrix. We're going to call this is um Toeplitz matrix, right? Because this is going to be this one right here. Um, so we have the big vector and the small vector within. 1, 2, 3, 4. Uh, 5, 1, 2, 3. 9, 5, 1, 2. So this should return true. So let me show you guys how this is actually looking like. Right. Here we go. So this is what it would look like, and then I'm going to make another vector as well in the matrix. Um, I'm going to call this isn't, right? And then this is just going to be 1, 2, and then 2, 2. Right. Now we want two bools. So bool, I'm going to say is Toeplitz is equal to solution dot is Toeplitz matrix, and then we're going to call in is Toeplitz matrix. I don't know if it's going to throw an error because they are the same name. Let me just change it to Toeplitz matrix then. Um, and then another bool as well, not um Toeplitz, because this we know this is going to be false. Solution dot is Toeplitz, and then we're going to say isn't Toeplitz matrix because we already know it isn't one. Now here we're just going to print out a message. So SCDC out is matrix Toeplitz. And we're going to put this in parentheses. We're going to call in the first is Toeplitz. So is Toeplitz let's say true or false, right? So this is going to say if it's true, it's going to print out true, and if it's false, it's going to print out false. And then for this one, we're just going to say not Toeplitz. So if you run this, this first one should return true, and this second one should return false. And if we run this, as you can see, we already know that this one is going to be true. Let me fix how this looks like. As you can see, it's true. And then this one is false. And if we copy this, paste this into here and submit it, um, you can see here it passes all the tests. Okay, and I'll show you guys what's exactly happening on my iPad right now. So within our function, we declared int rows to be matrix dot size, and then int columns to be matrix at array 0 dot size. So just again, brief explanation as to what this is doing is 1, 2, 3, 4, 5, 1, 2, 3, 9, 5, 1, 2. So this is the example we had. These ones are the big vector, and then each one of these are mini vectors within the big vector. So this is going to count how many mini vectors. The rows is going to count how many mini vectors we have within the big vector, which is going to be 3. And then column is going to count the amount of elements within the first vector, which is this one right here. And this is going to be 4. Okay, so then after that we had a int is Toeplitz. And we're going to set this to true. So we're just going to assume that the matrix that we're inputting is in fact a Toeplitz. Okay, so after that we have our for loops. So for row is equal to 0, while row is less than rows minus 1 plus row, and then for column is equal to 0, column is less than columns plus 1, minus 1 plus column. So this is saying while row is less than 3 minus 1, so while row is less than 2, and then while columns is less than 4 minus 1, while columns is less than 3, we're going to be looping, right? So now we want to compare the elements within the matrix. So remember 1, 2, 3, 4, 5, 1, 2, 3, 9, 5, 1, 2. If we're starting off in our very first iteration, what we're going to be doing is comparing our current row and column to row plus 1 to matrix at row plus 1, column plus 1. So here, if we're starting off here, this would be at 0, 0, row 0, column 0. We want to compare it to row plus 1, column plus 1. So essentially, we're just adding 1 to this. So 0 plus 1 is 1. 0 plus 1 is 1. So we're going to be comparing element at 0, 0 with element at 1, 1, which if we go here, this is 0, 1, and then 0, 1. We're going to be comparing it to this one, right? And if it's true, we just keep on comparing. So we wrote that as if matrix at array row and column is equal to matrix at array row plus 1 column plus 1, we're going to say is Toeplitz is true. So keep it as true. And then we had an else if statement. So else if, and then I'm just going to copy this. If matrix at row and column does not equal matrix at row plus 1, column plus 1, is Toeplitz is equal to false. And then we break because we don't need to keep iterating. We already found out that it's false. We don't need to check any of the other elements within. So that would be this break. First break would be in charge of the first would be in charge of the inner loop, so the columns. And then after this we have 1, 2. We had if, and another if statement, if does not equal is Toeplitz. Break. So this is just breaking the outer loop, so the rows loop, so the first for loop, and then we just return is Toeplitz. So essentially what's happening here is if I copy this, what we're saying here is so at the very start of our loops, we're starting at row 0, column 0, right? So we're starting off with this element, right? So we're going to say element at 0, row 0, column 0. We're going to check with our first if statement, if matrix at current row and column is equal to the matrix at current row plus 1 plus current column plus 1. So this is 0, 0. If it's equal to 1, 1, because we just added 1 to both row and column. So this element is 1. And if we check right here, this is 0, 1, 0, 1. We're going to be comparing it to this element. So if this is equal to this, we continue. So 1 is equal to 1. This is true. Now we move on to the next column. So we're still in the inner loop, right? We check if, now we're going to check if 0, 1, not 0, 0, 0, 1 is equal to what? We add 1 to both sides. So this is 2 now. We add 1 to both row and column. So we're going to compare this to row 1, column 2. And if we do that, remember we're comparing this to this. So as you can see, 0, 1, this is still in the first row. And if we go 0, 1, 2, 0, 1, we're comparing it to this. So row 1, column 1. This is true, right? Let me just circle this one. Right, this is true, this is true. So this is true as well, because 2 is 2. 2 is equal to 2. Next, we check at element 0, 2 is equal to add 1 to both sides to row and column. 1, 3. So we're comparing row 0, column 2, 0, 1, 2, this element to that element, which is in row 1, column 3. So this is true as well. And now we did, as you can see, we did 3 iterations within the inner loop. But since we're 0 indexing, this is 0, 1, 2. And what do we say within our 2 for loops? In our second for loop, we said while column is less than columns. Right now we're on the 3rd loop, but technically it's the 2nd, quote unquote, because we're indexing on with 0. 2 is less than 3. If we were to add again and try to do the 3rd row, 3 is not less than 3. 3 is 3. So we just move on to the next loop, which is now the next row, right? So now we're checking these elements within this row. So now we'd be checking element 1, row 1, column 0 is equal to element at row 2, column 1. So we're checking if this is equal to this, right? Because this would be 0, 1, 2, 0, 1, 2, 3. So we're checking if row 2, column 1, this one, and this is true, right? Because 5 is equal to 5. Now we move on again. 1, 1 is equal to 2, 2. What is element at 1, 1? It's this one now. Compare it at 2, 2, which is this element. This is true because they're both 1, 1, 1. This is true. Now we move on again to element at 1, 2. Add 1 to both row and column. 2, 3. Compare 1, 2. This one to this one. This is true. 2 is equal to 2. And here we would break again because we've already done 3 loops, or we're on to the second index, which is right here, right? 2 is less than 3. If we were to try to do 3, it wouldn't work. The conditions wouldn't work. And then this would be the end of our outer loop as well, because if we try to add 2 to row, or 1 more to the row, remember when the first, this is technically all of this right here. Let me change the color actually. All of this is in row 0, quote unquote, which is technically just row 1. And then all of this is in row 1 or row 2, right? And this is 1, 2, right? So now we check this in our second row loop. This is at what, 1 right now. 1 is less than 2. If we try to add 1 more, 2 is not less than 2. 2 is 2. So we would end it there. So now we know that all of the elements, now we know this whole matrix right here is a Toeplitz matrix. Now for the other example that we had 1, 2. Let me change this to 1, 2, 2, 2. We start off at element 0, 0, and see if it's equal to element 1, 1. In this case, this is a 1 and this is a 2. This is false. So we immediately, after that, we immediately set Toeplitz to be false. It's equal to false. And after that, since we are in this one, it would end the iteration for the columns, which is going this way. It would break out of here. And then since we don't need to iterate down below as well, going for the columns, we use this one right here. If does not equal, or if not is Toeplitz, which means the opposite of whatever Toeplitz is, which is true. So if it's false, we break. So essentially this is saying if Toeplitz is false, we break. So like here, like how we have here. And that would return false. And then again, this one would return true. So yeah, that's a brief little explanation on how this problem is being done step by step with the code, right? Just drawing it out for you guys. Thank you guys for watching. Hope you enjoyed.